Okay, in this video we are doing the Chapter 7 review. You got a new version of this green cheat sheet. So again, just talking about graphing, don't forget your table, and that 0 will never work. And then we make our table, we're going to use our A over X. Here's all the transformations, flip, stretch, and compress. For H, do the opposite, left or right. K is up or down. And you got your steps. With the simplify, multiply, or divide, don't forget with division there's copy dot flop. And then on the back, you're going to see similar directions between adding, subtracting, and solving, except that in the solving, we will eventually let the denominators go. So having that in front of me, we're going to get started. So the first thing we're going to do is sketch a graph of this function. I'll make my table, and I'll put those numbers in there. I just have a habit of putting 0, so I'm going to leave 0 out. When I make my table, I will use the A over X. So my table will be made with 1 over X. The 2 means I'll go left 2, and the 3 means I will go down 3. And if you want to go ahead and move your wall left 2 and down 3, you are more than welcome to do that. This graph looks a little weird, but oh well. So putting a negative 2 into here, I get negative 1/2. Here I get negative 1, and then here I'll just get the opposites. If you don't want to graph the fractions, that's fine. You can just graph, remember this will be our new center, this is our new x and y axis. This will be negative 1, and 1, 1, and that's fine. That's all you need. Just remember that they always curve towards each other, and they're always catty corner from each other. So dealing with domain and range, this arrow will not get stopped going right, but it will get stopped going down. And then this one won't get stopped going left, but it will get stopped going up. This arrow will get stopped going right, but it won't get stopped going down. And this one will get stopped going left, but it will not get stopped going up. So then I've got all of those things. So remember, these are just opposites. Not almost. I left my negative out of this one. These are pretty much the same, except the infinities are opposite, and the same with here. The infinities are just opposite. So my domain is smallest x to biggest x, so negative infinity to negative 2. Then the wall stops it for a while, and then it picks back up with negative 2 going to infinity. And then my range is smallest y, negative infinity to negative 3, and it gets stuck. Whoops, that should be my negative infinity. It gets stopped at the wall, and then it will just pick back up at that negative 3. So it should be negative infinity, negative 3, and then back to negative 3, infinity. The equation of the horizontal asymptote, remember this is y flies by. That's y at negative 3, and x is depressed. That is at negative 2. So the horizontal is y equals negative 3, and the vertical is x equals negative 2. And you do have to include the x or y. You just can't put the numbers. All right, this one, here goes my graph. We're going to make my table. Again, 0 doesn't happen. We will have a flip and a stretch because of the negative 4, and then everything will go right 3. So I will use the flip and the stretch in my table, and if I put negative 2 in here, I get 2, put negative 1, we get 4, and then these are just the opposites. This right 3 wall will put me here, but there is no up or down wall, so we'll just stay right, and then I can graph. Let's see, from here, negative 2, 2, and negative 1, 1, 2, 3, 4, and get that shape. And this one, I'll go 1, negative 4, and 2, negative 2. Let's go ahead and get those arrows filled out. So this arrow will not get stopped going left, but it gets stopped going down. This one will get stopped going right, but not up. This one won't get stopped right, but it will up. And this one will get stopped going left, but not down. And again, just notice the pattern. It's just the infinities that are opposite, the infinities that are opposite. So my x to biggest x, and then this one, smallest x to biggest x. And then the range will follow the same thing, except there will be the zeros instead. Your horizontal, that's your y flies by. We're flying by at 0, and our x is depressed. We're depressed at 3. So the horizontal will be y equals 0, and the vertical will be x equals 3. Again, make sure you include the x and the y. All right, in the first couple problems, so we are simplifying. Pay attention to what's going on. This is just simplifying a fraction. So going to our cheat sheet, anything that looks like simplifying just a single fraction, multiply or divide, make sure you factor all the numerators and all the denominators. Be sure to look for a GCF and difference of squares, and make sure you cancel out factors, not terms. So this, there is no GCF, but I can make my x. I need factors of -12 that get me to 4, and that will be a 6 and a 2, with the 2 being negative. So here go my parentheses, dropping those x's in there, and the x's are enough because x times x makes x squared. So x can follow this loop to make 6x, and then x can follow this loop to make a -2. As far as my denominator goes, there is not a GCF, but this is a difference of squares. And then I can cancel out my common factors. All the parentheses go or none of them. So don't take out a term. Don't take out x and x. That does not work. So when I'm done, I'm left with x minus 2 over x minus 6. Now in this one we're adding, and then the simplifying just means clean it all up. So if there is subtraction between the fractions, add the opposite between the fractions if needed, which there's not. We're going to see if we already have an LCD. If not, we're going to factor that denominator completely. So don't forget to look for GCF and difference of squares. And if you can't see the least common denominator, make that table. So this one has an x squared, and this one has an x minus 3. So if you did make your table, fraction 1 has an x squared, which you could technically factor into x and x. And then the second fraction has a whole new thing, so it's x minus 3. And if you bring everything down, you need x, x, x minus 3, which simply put is just x squared with x minus 3. So this one has the x squared, but it will need the x minus 3 on the bottom, and whatever you do to the bottom, you do to the top. And that's what this step says. Multiply each fraction by the factor it needs so that each fraction has the LCD. Whatever you do to the bottom, you do to the top. So this will need an x squared. Whatever I do to the bottom, do to the top. Simplify and clean up the numerator. Bring along the denominator. So the denominator will stay at x squared and x minus 3. The work will happen in the numerator, which if you just look at the numerator, I'm going to put that down here, you have a 5 with an x minus 3 multiplying, and then you have a 6 multiplying with an x squared, which I'll just make already at 6x squared. Then I'm just distributing that 5 through, and when I'm done, I need to put it in standard form, so 6x squared plus 5x minus 15, and then that one is done. All right, let's move on to the next page. So here, this is subtraction. So this is where I want to follow. Let me move some things out of the way here. To add the opposite between the fractions, sorry, if needed. So here I will add, and I only apply it to the numerator. Second thing I'm going to do, check to see if you have an LCD, which we definitely do not. So we're going to have to factor the denominators completely. So for the first fraction, there is no GCF, so I need factors of -10 that make 3. And that will be 5 with a -2. So I'm about to replace this, dropping in my x's, and x is enough to make x squared, so x can loop here, the positive 5 to make 5x, and x can loop here with a -2 to make a -2x. As far as this one goes, I need factors, again there's no GCF, I need factors of 15 that make 8, and that will be a 5 and a 3. So making those x's, or parentheses with the x's. So x can loop here with the positive 5 to make 5x, and x can loop here with a positive 3 to make the 3x. Hopefully you can see that least common denominator. You know, they both already have an x plus 5, but this one will need an x plus 3, and this one will need an x minus 2. If you don't see it, then you can make that table. So fraction 1 has an x minus 2. I'm not going to put the parentheses right now, and an x plus 5. The second fraction has the x plus 5 as well, but an x minus plus 3, which will start the new column. And you can bring everything down, and everything needs an x minus 2, and an x plus 5, and an x plus 3. So I will give this one the x plus 3, and I will give this one the x minus 2. So that's what we're doing here. We're going to multiply each fraction by the factor it needs so that each fraction has the LCD, and whatever you do to the bottom, you do to the top. So again, this one needs an x plus 3, bottom, top. This one needs an x minus 2 on the bottom and on the top. You're going to simplify and clean up the numerator and just bring along the denominator. So in the end, my denominator will be an x minus 2, an x plus 5, and an x plus 3. My work will be in the numerator. So for this numerator, in my first fraction, I have a 4 with an x plus 5, a new plus sign with a negative 2 with an x minus 2. So I can just distribute, get 4x with 20, negative 2x with a positive 4. Then I'll combine my x's for 2x. I'll combine 20 and 4 for 24. And then that's great. Just leave it like that. Number 6, another multiply and simplify. These will be similar, except this is a copy dot flop and this isn't. So as far as these directions go, again, just make sure you factor all the numerators and all the denominators. So 5x cubed, you could factor it if you really want to. You can make it 5 and x and x. The denominator, there is no GCF, so if I make my x, I need factors of 7 that get me to 8. And that would be a 1 and a 7. So making those parentheses with the x's in there, and x is enough to make x squared. I can have x loop with a positive 1 to make 1x, and x loop with a positive 7 to make the 7x. For the second fraction in the denominator, there is a GCF. It will be an x squared, which I'm actually going to write as x times x. And then you'll be left with an x minus 2. And as far as the numerator goes, I need factors of negative 2 that get me to negative 1, and that would be a 2 and a 1, with the 2 being negative. I'm going to make my x's, or parentheses again, drop those x's in there, which is enough. X times x is x squared. So x can loop here and make negative 2x, and then x can loop here and make a positive 1x. And now I'm ready to cross everything off. So an x plus 1 and an x plus 1, an x minus 2 and x minus 2, an x here, an x here, an x here, and an x here. I can cross off those single x's because they're factors. They're hooked together through multiplication. Okay? What I can't do is just take out this x with this x, because x is a term. It's connected through addition. So as far as being done, when I'm done, I have 5x in the numerator and x plus 7 in the denominator. This one is divide, so we're going to copy and factored form dot and flop. So starting with my first fraction, we're going to make my x over here. There is not a GCF, so I just need factors of negative 6 that get me to 1. And that would be a 3 and a 2, with the 2 being negative. Making my parentheses, dropping the x's in there, and this time x and x won't be enough to make 2x squared. So I'm going to have to put a 2 with one of those. And then since x can make either of these, I'm more concerned about 2x and the fact that if it loops to these parentheses, it'll need a negative 1 to make the negative 2x. And that means x can loop to here to get a 3x. As far as my denominator goes, I need this. There's not a GCF, so I need factors of 6 that get me to negative 5. And that will be a 2 and a 3. Be really careful. You might think 1 and 5, but it's 2 and 3. So making these parentheses and putting the x's in there. The x's are enough to make x squared. So x can loop with a negative 2 to make the negative 2x, and x can loop with the negative 3 to make the negative 3x. Now I'm going to, there is no GCF. This is not a difference of squares, so this one will be left untouched. This one does have a GCF. I can take a 5 out, and then I'm left with x minus 2. So as the directions said, I factored all my numerators and denominators. I did look for GCF and difference of squares, and now we're going to cancel out the factors and not the terms. So x minus 2, 2x plus 3 is 2x plus 3, and then that's it. In the numerator, you'll be left with 5 and x minus 1, and in the denominator, you'll be left with x minus 3. All right, we're getting simplifying. So again, just for simplifying, you're just going to factor all the numerators and all the denominators. So I'm going to start with my numerator. Really not quite sure what's going to happen here. But there is a GCF of a 4 and an x cubed. And when I'm done, and I'm left with an x minus 8. So that's as far as the numerator is going to go. Because x minus 8 is not a difference of squares. In the denominator, I'm going to do that over here in red. There is a GCF. I can take a 2 out, and I'm going to take an x out. And that means I'm left with an x squared. Here I'm left with a minus 5x, and then here I'm left with a minus 24. And now this 2x can go right here as far as the GCF, but I am going to keep factoring this x squared minus 5x minus 24. So factors of negative 20, negative 5 would be an 8 and 3, with the 8 being negative. I'm going to make my parentheses, drop in those x's, which are enough. X and x make this x squared. And then x can follow this loop for negative 8x, and x can follow this loop for 3x. So I think the more noticeable one is x minus 8. But this 4x cubed, just to show you, I could have factored 4 down into 2 times 2, and x cubed down into x times x times x. So from there, again, anything connected through multiplication signs is a factor. One of these 2 can take out this 2, and one of these x's can take out that x. So when you're done, in the numerator you have 2x squared, and in the denominator you're only left with an x plus 3. Okay, let's keep going. Number 9. This time we are adding and subtracting, so just a reminder of those directions. There is not subtraction. We do not have a least common denominator, so we're going to factor the denominator completely. This one you cannot factor. This does not have a GCF, but it is a difference of squares. And I'm hoping this is a little simpler compared to some of the others, and that you can see the least common denominator. Both fractions need this. So this has the x plus 3, but it needs an x minus 3 on bottom and on top. Okay? And so now we did this. We multiplied each fraction by what it needs. So we're going to simplify and clean up the numerator and then just bring along that denominator. So the denominator is set as x plus 3 and x minus 3. The numerator, however, this one never changed, but this one has a 4x with the x minus 3, which can leave me with 4x squared minus 12x, and then the x terms can combine, so when I'm done I'll have 4x squared minus 9x. Done. This one is very similar to that's on the capstone, that's why it's here again. We're going to copy dot flop, and I am going to, because we are simplifying, factor everything. So again, we might not think that we can factor everything, but 12 can fall into 4 and 3, and 4 can fall into 2 and 2. So 12 I'm actually just going to turn to 2 times 3, x squared and y. 4 can factor into 2 times 2 and y3. And then I'm going to dot, and when I dot this is going to flip. So y2 will go on top and x5 will go on the bottom. And now, instead of one big problem, 3 little problems. So the 2's cancel out because they're factors, they're connected with multiplication. When I'm done here, this is where I subtract the exponents, so I end up with x3 in the denominator. And then here in the numerator, I actually have y3, which can just cancel that whole y3 out, so there are no y's left. So when you're done, the only thing that's left as far as the numbers go, those coefficients, are 3 in the numerator and the only thing left for the variables is an x cubed in the denominator. All right, a few more. Hopefully I can get this done before the next class starts. So here we're going to solve. So very similar to adding and subtracting. Let's go ahead, and if there's subtraction in any of these, let's get that fixed. We're going to add the opposite, and we're going to do it to the neighbors. So here's subtraction. I'm sorry, not to the neighbors, to the numerator. No, no, yes. All right, what we want to do is factor the denominator completely, look for GCFs and differences squared. So none of these have a least common denominator. So maybe you can see that all the fractions here need a 3 and an x. Again, if you don't see it, here's fraction 1, fraction 2, fraction 3. Fraction 1 has an x, fraction 2 has a 3, fraction 1 has an x. Bring it all down, and they all both need a 3 and an x. So this one will need the 3, bottom and top. This will need the x, bottom and top. And this will need the 3, bottom and top. So now that I have a common denominator, let it go. Everything's going to be in the numerator. So this fraction's numerator will be 15. This one will be negative 1x. And this one will equal 3. To solve for x, I don't have to factor. I'll subtract the 15 over. And I will divide by negative 1, which gives me a 1 as my answer. Now, check for extraneous. The only thing you have to look at is if you put 1 back into your problem, will it make your denominator 0? Because that's the only thing we have to worry about. You can't divide by 0, and we're good. For this one, hopefully you can see the least common denominator, that all the fractions needs an x minus 8 and an x plus 2. So I'll give this one the x plus 2, bottom and top. Hello, I'll give this one an x minus 8, bottom and top. And I'll give this one an x minus 8, bottom and top. So now that I have that common denominator, we can let it go. So this fraction, as far as the numerator goes, has the original 7 with an x plus 2. There's my equal sign. This will now have the 1 multiplying the x minus 8, which I'll go ahead and put it there, but the 1 doesn't do anything for us. There's the plus sign. And then our third fraction, is going to have an x plus 7 and an x minus 8. That one's going to take a little more work. Let's go ahead and simplify and clean this up. So I get 7x plus 14. 1 times that is g. But here, this is a little bit more. So first I'm going to get an x squared. And then I'm going to get a negative 8x. Let me write that out. And a 7x, which when I put those together give me a negative 1x. And then a 7 with a negative 8 is a negative 1. So let's really clean this up. So left side will stay here. Let's clean up the right side a little bit. So I have an x squared. The 1x here and the negative 1x here will cancel out. And the negative 8 and the negative 1 will make a minus 9. And now, because I do see more than one type of x, I'm going to bring everything over and let the leading term in standard form be positive. So I'm going to subtract the 7x over. And then I'll subtract the 14, which when joining with the 9 gives me a negative, 23. Oh, I didn't make this problem. Oh well, okay, we're good. So what I want to look for now are there factors of negative 23 that make negative 7. And let's back up because I did not do this right. I'm just realizing 7 and negative 8 is not negative 1. I added them, so maybe some of you already caught that. It's actually a negative 56. And when I combine that with negative 8, let me get my white out again, will be a negative 4. All right. Okay, so you're fine. The mistakes keep rolling here. All right, so I put the 64 on the incorrect line. So let's just review what I did. I distributed my 7, got this. 1 distributed, didn't really do anything. And then I did not multiply, I added there. So that was a negative 56. When I put the negative 56 with the negative 8, that makes this a negative 64. And when I get everything on one side so I can factor it, when I subtracted the 7x over, so that's why it's x squared minus 7x, but when I subtract 14 from a negative 64, I get a negative 78. And this we will be able to factor because there are factors of 78. You would probably want to use your factor program. that get you here, but those are a 6 and a 13, and with the 13 being negative. You can't really see the one. So here are my parentheses now for factoring. X and X are enough because they make the X squared, and X loops with a positive 6 to make the 6X, and then X can loop with a negative 13 to make the negative 13X. And now what makes these 0 is 13 and negative 6, which are not extraneous solutions, because putting 13 into here does not make my denominator 0, and putting negative 6 into here also does not make my denominator become 0. All right, we're going to run out of time here. Hopefully I can get this all done before the bell rings, but let's see, what time is it? Sorry, I'm just checking the clock. 1:50. Nope, I might be able to do it. Okay, solve and check for extraneous solutions. So here, if you notice, there's already a couple of 8x's, so we're just going to give this one the 8x that it needs. Whatever you do to the bottom, you do to the top. I'm going to let that denominator go much shorter now. I'm going to go ahead and multiply the 3 with the 8x to make 24x. And I'm going to add 1 to over here. And then I'm going to divide by 24. So when I'm done, my answer is 6 over 24, which is also 1/4. Finally, least common denominator. I need every fraction to have a 2 and an x. So this one has it. This needs a 2. And then this one, which is currently over 1, needs a 2x. Now that I have my common denominator, I'm going to let that denominator go. I've got 1 equals 2 times 2, which is 4, plus 1 times 2x, which is 2x. I'm going to subtract the 4 over, which is negative 3. And then I'm going to divide by divide by 2. And then x equals negative 3 halves. This is a good one to also put as a decimal if you want. And that's the review with enough time.